Hey, welcome back to Engineers Workshop. We are going to continue working on the pulley spacer. This is a harmonic balancer spacer for my son's Spitfire project, and it is a weldment. So we've got a 2.5-inch OD tube, end pieces. They start out as 3/4 inch thick solid steel. It's got a number of tricky features on it. So I was talking with my son. We put our heads together on this, double-checked some dimensions, and conferred on the best way that we thought to move this forward. So right now I've got one end, got the bore cleaned up in here, 30-degree V-groove for the OD weld on the one end of the tube. Tube is not to length yet, it's very long. And I just put the end piece, the first end piece in the lathe. Actually, I'm going to do this one first. So let me show you a little bit close up on the drawing and what our strategy is from this point moving forward. Okay, so the other day that I already discovered that the hole in the actual harmonic balancer was 1.1845, so that dimension is going to have to change to pilot better there. My son just confirmed that the length is 3.625, so that's going to change. And this diameter we have yet to confirm. So first thing I'm going to do is to rough out this little shoulder. I'm going to keep it oversized, but I'm going to make it so that, I've got a feature, a diameter here and here that's going to run concentric to one another. Then I'm going to put a nice lathe center in here. And on the far end, I'm not going to put in this bore really at all initially. I'm just going to put the same lathe center in the other piece. So when I've got rough diameter OD that will fit into the tube, and actually my son told me don't do a press fit. He said just do a transition fit or a slip fit. That way he can put the two ends on, phase them accurately one to another, and he'll just use through bolts to hold everything together while he welds this. So that sounds like a good plan. I would kind of prefer to have both the press and the weld holding this thing, but he has good faith in his welds. He is a good welder. And this thing's going to be under a lot of compression from the bolts holding the harmonic balancer to the timing pulley. So I'll go ahead and I'll do a slip fit for these. The other thing that we may have to do is that this face that's running right up against the timing belt pulley, I believe the face of the harmonic balancer served as somewhat of a lead-in for the timing belt, so I may have to tick these edges back here at 5 or 10 degrees. I'm not sure this is any bigger though in diameter than the timing belt pulley itself, so we'll check that when we're over there, but that's the strategy moving forward. So we're going to start here, get that shoulder, get a lathe center, then I can flip it and grab that and fit it to the tube end that we just turned. I don't know if we'll get that far today, but we'll see how we do. Well, that edge, I'm pretty sure, is about shot, but it is the only thing that will fit in between those chuck jaws to give me a cleaned up OD. I can switch over to a different tool to turn that shoulder. Try a little bit of high-speed steel tool here just to see if this will cut, and then I can do that step real nicely with this. That's actually cutting really nice. Now I don't have to make this diameter, the rough diameter, anything too critical. I'm at 1 inch 350 thousandths now, and I'm going to go down to them about 50 thousandths over the actual fit that I need, which means I need to take about 100 thousandths off the diameter from here. So I'll dial in until I start removing metal and remove 100 thousandths more. That's 50, just making sure I'm not going too far. 290, 1 inch 290. Yeah, I can go another 50. Okay, at this point I'm going to take additional cuts, maybe 20 thousandths deep. Let's try that until I have a 3/16 deep shoulder. It's having such an easy time. Let's try 30 thousandths at a time. Coming up on the original cut here. Might be running a little fast for high speed. I'm going to try increasing my feed. I was really only running about a 2 thousandths feed. Now I'm going to be running 6 thousandths. Okay, time to check our depth. Almost exactly an 1/8 inch. So another 60 thousandths, so we'll do 2 more passes. Okay, I'm just going to plunge in and do the tiniest of cleanups to this. .2395. So basically now this diameter and this diameter will run true, and I will flip the jaws around. We'll grab this, and I'll turn the OD to fit into the tube end. A little warm, but not too warm. Okay, I've got everything flipped over and running within about 1/1000ths. So I just will take a little bit more of a cleanup on the OD, stop it when it gets near the chuck jaws, and then I'll start making a step for the fitting in the tube. See where we're at on the diameter. I got to get the speed back up. I think I'm just going to run with the compound because the feed is right now is a little bit too aggressive. So let's take a shoulder cut about 1/4 inch deep. In fact, I'm going to reset my stop here. Take a measurement, see where we are. Two inches, 458 thousandths. And we've got to come down to 2.2700. So basically 2 inches, 2.41. I'm right at about 100 thousandths left to go. Three passes at 30 thousandths each, and then a cleanup. Yep, right at about 10 thousandths over size. So let's shoot for dead nuts and see if they just slip together. I don't think you could ask for better than that. Now we got to figure out how to put a little bit of a weld lead in on there, just like I did there. Basically, I'm going to try to get right in there and then just run the compound. Okay. Back to way slower. There we go. So nice generous bead there where he can lay weld in there. It'll be almost full penetration of the diameter of the tube. Hopefully still enough material where we can indicate once we've, have to start grabbing this thing on the OD, because we're gonna have to turn down that weld bead, but there you have it. I'm pretty pleased with that. Not much clearance in there at all. Well, I hope you enjoyed that. Got one end done, at least for the rough work. And the important point is now it's a slip fit. He can adjust the, relative positioning of that. We'll fit the other side. We'll take the two discs over to the K&T, and we'll put the 4 mounting holes in that oddball pattern. I kind of got it figured out what it is. I'll show you that in the next video. Then he will clamp it together, weld it. We'll bring it back over and we'll do the finishing cuts to bring that diameter down to the final diameter that'll pilot in the harmonic balancer. And the other side, we have to put a hole in to clear and pilot on the, I believe it pilots on the OD of the mounting bolt flange. It's kind of odd, but that's what it does. So hopefully it'll work out and hold up under the stresses that engine will dish out. So anyway, thanks for watching. Thanks for subscribing. Probably 2 more videos in this series. And till then, stay safe. Thanks again from Engineers Workshop. Take care.